Macro placement involves the placement of the large components, of which there are usually not more than 100 on a chip. But on account of their size and their very different heights and widths, they are not easy to place. Moreover, one has to take into consideration that all the components are interconnected with nets, which should be as short as possible. You can obtain an impression of the complexity of the macro placement problem by trying to solve our placement game. How then is the macro placement step accomplished? For a start, we note that for any two macros, each can only lie to the east, or west, or north, or south of the other. That is, there are only 4 relative positions. If, for every pair of macros, one knows their relative position, then one can formulate the macro placement problem as a linear program. The dual of this problem is a so-called min-cost flow problem, which can be solved very quickly. So it remains to determine the relative position for every pair of macros. One could try to do this by checking all possibilities one after the other. But the number of such possibilities grows very rapidly indeed. For 2 macros, there are just 4 possibilities. For 3, there are already 4 times 4 times 4 equals 64 possibilities. For 4 macros, there are 4 times 4 times 4 times 4 times 4 times 4 equals 4,096 possibilities, and so on. In general, for n macros, there are 4 to the power of n over 2 possibilities. This number grows so rapidly that the fastest supercomputer is hopelessly inadequate for checking all the possibilities for just 10 macros. But mathematics provides a way. For a start, one notes that it is unnecessary to check all the relative positions of a pair of macros. If, for example, macro B lies to the west of macro A, and macro C lies to the west of macro B, then it is immediately clear that macro C must also lie to the west of macro A. So, for a pair of macros A and C, the number of relative positions has been reduced from 4 to just 1. Using this everywhere substantially reduces the number of possibilities that need to be checked. But one can do much better than that. In any particular placement, most pairs of macros have 2 relative positions. For example, macro A lies to the east and the north of macro B. This reduces the number of possibilities to be checked as long as one makes sure that every placement can be realized by at least one choice of relative positions of the 2 macros involved. Using this approach, it was recently possible to substantially reduce the number of relative positions to be checked. Problems with 10 macros can now be solved in only a few seconds.